In this work, we present empirical results about the nature and articulation complexity of user-defined gestures performed from the wheelchair space with the goal of understanding wheelchair users' preferences for on-body, in-air, and on-wheelchair gestures to control interactive systems. To this end, we conducted an exploratory analysis of user-defined gestures performed from the wheelchair space by using a public dataset collected from 11 wheelchair users with various motor and mobility impairments. To extract information about gesture nature and articulation complexity, we used a combination of McNeil's gesture theory and a taxonomy from human-computer interaction introduced for gesture elicitation studies for purposes of interacting with computer systems. For example, we grouped participants' gestures into 4 categories of gesture nature according to the expressivity of the underlying movement. We also considered 4 categories of gesture motion type representing the spatial and directional description of a gesture in relation to the user's body. We found that about 50% of the gestures proposed by the wheelchair users from our study were deictic in nature, and about 50% of the gestures were directed towards the body. Also, we found that gesture complexity scores were overall low since the elicited gestures consisted in either one or two elements of the articulation complexity. To better understand our results, we looked at the relationships between the nature, complexity, motion type, and production time characteristics of user-defined gestures. For example, we found a statistically significant negative linear correlation between gesture complexity and the percentage of observed deictic gestures. Based on our findings, we suggest the existence of a potential expressivity complexity trade-off for accessible gesture input to be examined more closely in future work, including for other user groups, interactive devices, and systems that use gesture-based input. Also, our results have implications for designing gesture-based interaction for the wheelchair space, for which we suggest several future work opportunities, such as designing gesture sets in accordance with the body image representation and malleability of the peripersonal space, which may incorporate the wheelchair, as well as mixed nature gestures that feature both low complexity and rich expressivity. For more details regarding our study and results, please see our paper.